Hi guys, good afternoon. So today's class is going to be a short one. However, we do have some assignment and we are going to be designing this camshaft. So whenever this mechanism starts to rotate, the camshaft moves and it presses some buttons in a certain order, right? So the way I designed this is by pressing 1, 2, 3, 4, 5. Let me check. So quite slow video. However, we can see how these buttons are being pressed, and well, this is more or less what I tried to do. Okay, so to do that, to do these type of mechanisms, let's review real quick on the components that I used, and maybe it can be useful to you, right? So first we have the button. This is a quite simple assembly. The only relationship between them is that these are concentric. After that we have this base. So this base, I use these circles in order to make them concentric to the circle, to the button, sorry. Let me check what else. Also, well, we have the crank, and this will help us to set the cam in position, because we are going to be using this side to set the relationship well, to do set the values for all the cams using only one part of this crank. And after that we have the actuator, which will be actually touching the button, and I believe that's all that I used. Okay, so this is actually quite simple to model. Maybe the hard part here is going to be to add all the mates, because we have several. So as I was telling you, these are the type of relationships that I used. The first one was to fix the base in space, and after that I position all the bases for the buttons and set them accordingly by using this concentric relationship. Also, then I added the buttons, the actuators, the crank, and the only relationships that I used there was concentric. So we have a bunch of those. I also, to avoid these parts from rotating, I added a parallel relationship in relationship to this side of the base. And by the way, these files will be available in the share folder, so you can check them out later, well, in more detail. What else did I use? Oh yeah, so for the actuator I actually had some issues, because this part, as it is a rounded shape, whenever I try to make it with this flat surface, it tried to use a tangent relationship. However, sometimes it tried to rotate the button and it created a bunch of errors. So what I did there was only to position them accordingly and use lock in order for those two parts to move together. Okay, so that's for lock. What else? And to add the relationship, well, to create this spread out of the degrees in which these cams are positioned, let me check. We have right here a small table in which in the first position the cam 1 it's at 72 degrees, etc, etc. So why 72? well, these are all part of 72, right? So why 72? Because 306 divided by 72 equals, sorry, divided by 5, which is the number of cams that we have, equals 72. So it's evenly spread out, all these values. So that's why they are like that. Okay, so now we have to choose the order in which I want the keys to be pressed, or in this case the buttons to be pressed. So I selected 1, 2, 3, 4, 5. So it's a linear sequence, right? 1, 2, 3, 4, 5. 1, 2, 3. So you get the point. Okay, so the way I set those values was by selecting a parallel surface from the cam, and then set them in relationship to one side of this crank, the handle for the crank. So right here we have this flat surface that I use in each of these cams, and I set up the values, and this is quite easy. We had to use this standard relationship, and right here we have these values right here. Okay, so we set up the values. The first one 0, the second one 72, etc., etc. So actually, and after that, I also use an advanced position to center this mate, which is width. So to position the cam exactly on the midpoint for this actuator, I used this one that is advanced mates, and I use width. So if you remember, we select two surfaces from one part and two surfaces from another, and it will set these parts evenly or in the mid plane. So we can say see these relationships right here. So I selected these two faces and made them with these two faces, and that's how I got them to be positioned right there. And lastly, we have to add the relationship that is called, bueno, en español es posición de leva, relación de posición de leva. So to add that, we need to select two of these faces. Okay, so one face has to be a closed face, and the other one has to be just touching. Okay, so if we click here and see the values that I use, is actually asking me for two. One is the trajectory, and the other one is the face that it will be touching. So in this case, the trajectory will be the face of the cam, and the empujador de leva will be this face right here. Okay, so that's pretty much what I did, and it's quite straightforward, right? There's nothing complicated. I only wanted to help you practice this camshaft assembly type. So this type of assemblies, I mean, it can be somewhat outdated. I actually came with it by thinking about the pianolas. If you remember this one, it was a piano that you put a roll on it, and this roll has the key sequence in which the keys has to be pressed, right? So the real mechanism doesn't have to do at all with this type of mechanism, because the rolls have holes that allowed air to pass through, and the air was actually the force that pressed the keys, right? So in this case it's nothing like it. However, it does have some similarities. Real application in a more modern setup could be that you want to maybe make money by watching ads on internet, right? So you design your machine, you set up an actuator, and you can, I don't know, maybe add directly this cam in order to swipe every time, or you can set up maybe a speed in which you can double tap in something, I don't know, ads or videos or close publicity, I don't know. So that's maybe one case scenario. Another one that I can think of is that whenever you need to create a sine wave, maybe you have a project in which you need a very specific voltage. I don't know. You need to have the voltage and time, right? And you need the shape to be very specific, and you can design that more efficiently using this cam. And maybe right here it can be positioned to a resistance that will allow you to create a more complicated sine wave. I don't know. The idea here is that you practice, and maybe it can give you some ideas for future projects, etc. Okay, so these files, as I said, are available in the share folder, so go check them out, reuse them, and for your assignment you will have to design this camshaft. However, it has some variations because we only have 4 of these cams, so the degrees are evenly spaced. However, there is another variation here, that is that some of these points actually touch or are well, push the actuator in 2 positions, right? So it's quite easy. You will have to design another type of cam. Okay, this one didn't work. Okay, so the original one is something like this, right? So you will have to design a different one that is, well, mirrored, so we will have this shape like this. So these two are 180 degrees apart, so you can reuse this one for these values and use a regular one for this one. Okay, so that's it. If you have any comment or question, I will be available in my phone or in the computer, so just let me know if you have any questions. Okay, well guys, that's everything for today, so get to work. See you.